Evet değerli izleyicilerimiz, hızla devam ediyoruz. Son iki konuğumuzu alacağız, iki bölümümüzü yapacağız. Biraz data konuşacağız, datanın ölçeklenebilirliğini konuşacağız. Şakuda kurucusu ve başkan yardımcısı Stella Wu bizimle. Hemen kendisini sahneye alalım. Stella, welcome to Istanbul.
Hi everyone.
Hi. If your presentation ready, you can take the stage from us. Thank you.
Yeah. Oh, share my screen. Great, thank you. Hi everyone, my name's Stella. I'm joining you from Shakudo here in Toronto, Canada today. Great to be here. At Shakudo, we build operating system for data and machine learning, and today we're helping a lot of companies scale their large language model applications fast. Today I'm going to talk about how to talk to your data at scale. So we all know LLMs has been phenomenon and then changed how we work and retrieve information and knowledge. However, it doesn't have all the information that we have about our internal knowledge base. So one evolving technique to supercharge LLM with your internal knowledge base is a retrieval augmented generation. That's what we call RAG. And with RAG, arrays many of the vector databases that store internal databases. So the idea is now you can embed everything through a language model to be used as background information for our LLMs and to answer questions more relevant to you and your organization. It gives the LLM a guideline of where to focus on the text generation and reduce hallucination, but not all, completely no hallucination. And RAGs also come with vector database wave from PyCon to Melvis to Vivid, and a lot more are coming these days to store the embeddings of your internal knowledge base. Open source LLM and internal knowledge base has become a popular setup to stand up your internal chatbot for various use cases. For example, employee onboarding, research, analytics, and anything that you want it to be automated through about your internal information. Today, we're talking about how to deploy such a system in production and some of the common challenges. Okay. So the number one challenge, oh, I already talked about this part, I guess. Yeah, the number one challenge is the quantity and the accuracy. Imagine that we index all the PDFs and the decks in your OneDrive or your SharePoint in your company. We quickly ended up with huge numbers of entities in the database. And to be able to search at lightning speed across billions of entities is a challenge. And in addition, since we expect natural language queries, we need semantic search with contextual relevance. For example, if the user asks for the price of adopting a cat, CAT can be a stock ticker for caterpillar as well, or it could be the pet cat. But without contextual information, adopting cat clearly isn't about adopting a company, so the search will give bad results. The solution in practice is to use a vector database, which allows storing embedding vectors efficiently and retrieving documents based on embeddings at interactive speed. Setting up vector databases poses additional challenges. For example, correctly partitioning large data, which cannot fit entirely in memory, is not an easy matter, and doing it poorly can result in some queries taking up too much RAM or bringing down the service, which is under partitioning. Or if we have too many of the partitions, then the query is going to take too long to probe and find the relevant documents, which result in hitting slow permanent storage, and then the RAG will respond slowly, which is over partitioning. Both are not ideal scenarios. And in addition, the quality of embeddings chosen, the embedding methods, what to embed and how much of it is its own complicated topic. Poor choices can break a RAG altogether, while good choices will make the downstream generation task a lot easier. It's not enough to select whatever embedding model tops a benchmark, because the benchmark may not be using the data resembling your specific knowledge-based documents. For example, if the embedding of the model was trained on a Reddit threads, it won't do very good with your financial statements or your business case studies, for example. It's also important to understand the kind of embeddings used, since that affects how search metrics behave. Most modern embedding models use normalized embeddings, but not all of them. some common search metrics like L2 or cosine similarity will return different results in the case of unnormalized embeddings. As you can see in this equation, the cosine similarity divides by the vector norm, while L2 doesn't account for the norm at all. So depending on embedding types and desired results, both are viable, although in typical cases, cosine similarity results in expected behavior. So on the generation side, once we have the retrieval, we can generate the context obtained from the documents or documents retrieved in a database are provided to the model, and the model must now provide a natural language answer to the user query. Choosing the right LLM is critical for this. Well, you would probably say, let's just choose the biggest model that has beat the latest benchmark. Well, that probably is not always the best choice. There are a few fold of reasons. So chosen some of the models, even though it's bigger, doesn't perform as well as compared to the smaller models, although it has more parameters and it is bigger. For example, in some of our use cases that we tried, they're fine-tuned models based on chats. For example, Wizard LLM, it performs better than Llama 2 for the same number of parameters out of the gate because it's just fine-tuned better for the type of use cases that we're trying to do. And bigger models are also far more expensive to run and hard to scale, as well as generating a little bit slower. As you can see, GPT-4 generates slower than GPT 3.5. They are diminishing results in generating when increasing number of parameter counts, and the optimum for you may not be the same for someone else. Note that the logarithm scale on the x-axis compared to the almost linear reaction to the accuracy. So we have to have a lot more parameters as we go to increase the accuracy for a little bit. Better models will make the downstream engineering tasks such as guardrail engineering or prompt engineering easier, as the model will yield better results from the get-go, but it can never eliminate the issue since LLMs needs for massive data during training mostly limits them to being trained in text generation mode. So it is trained on generating text. So in brief, just as for embeddings, choosing the right LLM isn't simply a matter of choosing the bigger or the largest model or the latest model. How they're trained matters, and it might be necessary to fine-tune the model to get good results for a specific data of interest. In fact, there are many companies start to use SLMs, so which means smaller language model, but fine-tune them for a specific use case for real applications these days. Without prompting the model in the right format and with the right information, it is very likely to give sensible responses that are not related to documents of interest at all. Common techniques to improve output quality include inserting the phrase, "let's think step by step," or instructions like only answer based on the documents. This has the effect of improving the likelihood of generating tokens if those phrases were previously encountered in the model's training data. And the closer the phrases is to the data the model has seen, the better for the purpose. Correct prompt engineering is again quite challenging. Minor differences like punctuation and capitalization can have radical downstream consequences. This will also often be task and model specific. The significant trial and error experiments is required and is not always reproducible. In fact, it's not reproducible at all, most of the cases. Moreover, the prompt shaping can never fully eliminate hallucination. And a user can always bypass any prompt engineering effort with a little bit creativity. Projects like Melinda.ai have tried to address this issue, but hasn't gone so far about it. If the documents of interest in your recs are small enough, a powerful trick is to provide example inputs and output pairs in the prompt. This approach can improve output quality great, but again, it is not a fail-proof technique. Another tool that can help generation is guardrail engineering. There are many ways to go about it. but the most common is to stop generating when specific words are encountered. A classical hallucination pattern, since LLMs are trained for text completion and not dialogue, is that the LLM will keep generating the answer, although they already answered the question. So it will fake the user input and answer in the same dialogue and keep going. So using the user input prompt components as a stop word greatly reduced this issue, for example, although minor formatting issues in output could cause this guardrail to fail. And another common guardrail is to use when generating categorical results, which is round. A pear, an apple, or an orange is to verify is the categorical option are present in the output. This can be combined with stop words to prevent the model from outputting more than just the answer, so depending on the use cases. For example, in this use case, if we use the stop words, it will just stop at green. But if we don't, it will keep talking about the green. Why is it green? Unlike prompt engineering, this tend to be more task and model agnostic. For example, all models and tasks benefit from setting up stop word on the user prompt, but guardrail can't affect output quality or format by itself. It's just a technique after the text is already being generated. Unlike prompt engineering, and neither techniques can fully eliminate hallucination, but altogether, they can greatly sanitize the resulting generated text. The final challenge I will discuss is deploy at scale. LLMs are expensive. They're generally too slow to run on CPUs, so GPUs are expensive to run, and a lot of overhead moving data from the CPU RAM to the GPU VRAM, and meanwhile, the usage is not constant throughout the day. So, and we need a way to scale up and down as seamlessly as possible to avoid cost and also to avoid interruption of the services. So imagine if there's a service with millions of users, but variations throughout the day, then this has to be done in a more scalable and automated way. Aside of that, there's also a shortage of GPUs from NVIDIA altogether. So it's hard to run. It's hard to even get GPUs to run all those large models. As we can see on this graph, the flops are needed per token. So you can calculate pretty much how much GPU power that we need for one of the largest models. Well, as we go, this is already outdated in 2022, and many of the bigger there are also bigger models these days. All right, so the solutions like Shakudo can help overcome some of the challenges, alleviate the pain when deploying LLMs and RAGs. Shakudo is a operating system for data and machine learning. So it comes with all the components that you already need to set up a system like RAG. It manages all the infrastructure set up, so the users can focus on the machine learning part and can focus on the business value. So instead of spending time setting up the DevOps and MLOps, because in this space, in the LLM space, things change radically. We can think about what was relevant about 1 month ago is no longer the top news, and what was relevant 6 months ago is now just not even on the top scale. So it doesn't make a lot of sense to spend a lot of time on setting up the infrastructure. And what's most important for organizations to get the value from LLMs are to be able to set up the infra and everything about the tooling in one go, and then just focus on how to get the results and how to get applications to production. And that is the essence of all the things that I wanted to cover today. So in conclusion, we have RAG, which is a typical classical way to set up your internal chatbot. And talking to your data is highly desirable these days because the LLMs are not trained to know your internal knowledge, and everybody wants to talk to ChatGPT about your internal knowledge, which is not very secure if you just use it out of the gate, and also not knowing all of the things that you have in-house. So setting up RAG is a useful technique to do that, and there are a lot of overheads and challenges, and I just listed a few today. And as we go, the space will evolve and be more mature to fix those challenges and make things easier for us. And companies like Shakudo is here to help companies to overcome these challenges today, is to focus on your business values. If you'd like to learn more about how Shakudo is helping companies setting up rack solutions and things about how to put things in production, feel free to contact me after the talk, and I would like to discuss more about many of the things that we're doing today in the space. Okay. Thanks for your attention.
Thank you, Stella. We have one question for you, and from our audience, they asked you, do you have any projects or collaboration about local markets like Turkey?
Local markets like Turkey. We have some European customers. We don't have anyone in Turkey just yet, but we have friends in Turkey. That's why I'm here to give the talk. Yes.
Perfect.
Yeah.
Which countries in Europe?
We have some companies in UK.
UK. Okay. Thank you. Yeah. There's no question, I think. Thank you very much, Stella. This is the great. I'm sorry. It's great information. Have a take care of you. Bye bye.
Thanks so much. Bye.
Cheers.